Hi, folks. I wanted to talk to you today about Arena 16.2 and some of the changes that were made relative to earlier versions of Arena in reporting results that come out of models. This is a frequent question because a lot of the tools that have been previously developed to help people learn Arena were based off of Arena 16.1 and before. Those versions of Arena used a tool called Crystal Reports embedded within them to summarize the statistics from their models. Starting around Arena 16.1 and then sort of forced in 16.2, they started to summarize reports using a Microsoft Excel-based front end. And that is a very different experience to anyone that is looking for the old Crystal reports or is being instructed by some of the old tutorial material or textbook material that is out there. So today, I just want to show you how that works. So I've opened up Arena, and rather than building a whole new model and from scratch, and if you are looking at old materials, you also notice something that happened around Arena 16.1 is this project bar looks very different. They reorganized the modules, so you find them in different places. So they're just kind of grouped differently. They have kind of different colorings. There's a way to bring back the old template panels, but moving forward, it's just kind of good to learn where things are here. So there's that change as well, but I'm not going to build a model for you today. It's just so we can jump straight into the reporting. So instead, what I'm going to do is I'm going to, if you know that I went into the File menu, and I'm going to go down to Browse Examples. And these are some pre-built examples that Rockwell Automation has provided in order to help people learn Arena or test out their understanding of Arena. And so there's a bunch of these examples here. There's also the Smarts library if you're ever looking for smaller examples that show you how to do certain things in Arena. That's great to kind of go through these smarts. But I'm just going to go in this kind of simple examples. And there's these groups of examples here that all of them are pretty interesting to take a look at. I'm just going to zoom in on this assembly line here. So I'm going to open up that assembly line example. And so it's a little tiny here, so I will try to make it a little bigger. I'm going to hit the asterisk in order to kind of zoom in on it a little bit. And so you can see this is just kind of a basic assembly line here. It keeps track of things like work in progress. It takes packages that come in that there are these entities that are called Pika. So let's study this model for a little bit. So if we look at this model, we go to this data definition section here in the project bar, then we can go down to the entity, and then down here we can see the entities that are defined, and we can see that the entities here are called PICA, PECA here. Those are the things that arrive at this assembly line and then are moved through the assembly line in order to create the widgets that this assembly line does here. So we can see that those entities come in, and then there's a bunch of stations. And those stations have queues, and all of that logic is down here. So if you were to zoom in on this project, you'd find them down here. Now, normally, when you're looking at these examples, we could just run this example from here. I'm going to do something a little different just so we have a better opportunity to explore different ways to get data out of this model. And I'm going to go to File and say Save As, and I'm going to save this into a separate folder so that I can access the results that are generated a little more easily. So I've created on my desktop this folder called example, and I'm just going to save that assembly line into there. So now if I go into this example folder, then I see there's my assembly line.doe, which is exactly what I have here. So now if I run this assembly line, it starts out by default very slow. So you see these packages arrive. You see that these stations, as they're being used, then they change color to show their state. So it's kind of a nice visualization here. And so down here, I can see that it's going to run through 10 replications of this at this very slow speed. So we're going to speed that up. But I want to show you a couple of other things here too. So normally when we first introduce people to Arena, we have them explore the replication parameters. But where are those in this new interface? Because they've got this ribbon across the top. So older versions of Arena, you just can't find them in the same places. But there's now this Run tab in the ribbon. And underneath that, there is a setup. And then under that setup, you've got these sections here, and one of them is project parameters. And these project parameters tell Arena what sort of things you want it to automatically collect for you as outputs that you might be interested in. And so it's selected a bunch by default, stats about the resources, the queues, the entities, a bunch of these other things like transporters. There are no transporters in this model, so it doesn't matter if I turn that on. I am going to turn on costing. So these are variables having to do with if different types of processes cause different types of costs. So there could be value added costs. So a process could be doing work, and that's a value added cost. Or there could be a cost of an entity just standing in line. And so that's a non-value added cost or a wait. And so keeping track of those costs, how much does it cost us to keep something waiting? Arena can keep track of those things for you. I'm also going to turn on stations, and I'm going to turn on processes. Just because to show that we can turn some of these things on so that Arena can gather more data for us. You yourself can generate your own outputs and your own models. These are just kind of things that Arena knows how to gather data on already. So you don't have to define these ports in order to gather this data. So I'm just turning on this so Arena automatically gathers more data for us. The other thing I want to highlight is under replication parameters. By default, this model runs 10 replications. And so each replication is 8 hours long. It's like a work day. Just it's saying we have 24 hours in a day. That's just for time scaling. And we're going to run 10 replications, which means it's going to basically run 10 work days. So it runs through 8 hours, and then it resets the simulation. It uses a new random number seed, and then it runs for another 8 hours, resets the simulation, uses another random number seed, and so on. And it does that. And so that eventually you get 80 hours of simulation where each 8 hours is initialized by a new random number seed. So you can view each of those 10 replications as independent runs of this assembly line. There are some more advanced settings. These are not in the older versions of Arena, where you can actually, if you've got multiple cores on your machine, it can run these in parallel. So if you have, the ability to run 20 threads in parallel on your machine and you're asking for 10 replications, then that basically means all 10 can run at the same time. And so that allows you to finish these simulations a lot faster. We're not going to worry about that here because this simulation doesn't run that fast. This simulation doesn't require that much time to run. All right, so that's where we find our replication parameters and our project parameters. There are also some other things about run speed, which have to do with the default speed. We're going to play with that with the interface. Run control, which has to do with what it does between replications and so on, and so on. So then also reports. So at the end of the simulation, does it ask you if you want to open the report or not? We're going to leave it as its default. There's things that we can set up here. Now, I do want to pause here to point out that under reports, it talks about model statistics, overall and by replication, and then it also has SIMAN Summary Report. Those are your two options here. And basically, we're going to show both of those in this video. One of those is an Excel-based front end that I was talking about. The other one is a much more old-fashioned way of reviewing these reports in a text file that gets written out into this example folder. So we're going to leave it in the Excel-based front end. Most of you will probably prefer that, but I'm going to show you how to get to that SIMAN output as well, so that you have an alternative if for some reason the Excel isn't working for you. Okay, so that's our start here. So if I run this, so I can either go back to the home, and then there's the run control here, or within the run tab of the ribbon, I can hit run. And it by default runs very slow. I can crank this up a little bit. I can also hit fast forward, which will go very fast, or I can click batch run, which disables the animation entirely. And then it immediately runs through all 10 of my replications. So if you see down here, it shows me what replication it's run through right now. And so when I hit batch run, it finished all those replications so quickly that this almost immediately jumped to 10 out of 10. Now it's going to ask me, the simulation has run to completion. Would you like to see the results? If you hit no here, then that's okay. You can still get back to those results. So I'm going to click no, just in case, I ever did that. And if I ever want to get to the same place that it was going to take me in my project bar, I can click on reports, and that opens this up, and then I can click on model statistics. And at that point, it brings up Microsoft Excel. Now, this Microsoft Excel, by default, when it opens up, you're probably going to get this security warning. You notice that if I look in this example folder where everything's stored here, then let's see what these files are, and we can see exactly what's being opened up here and why I'm getting this security warning. Here's my assembly line DOE file. Now, as it ran, it created this assemblyline.db file, this database file. Those of you who are familiar with Microsoft Access, or maybe structured query language, SQL, those sorts of things, databases in general, this assemblyline.db is basically a database that stores all sorts of data about the simulation that you just ran. And this assembly line report.xlsm is an Excel-based front end to that database. So this file here, it looks like an Excel file, but instead of ending in XLSX, it ends in XLSM, which basically means it is a Excel file that has macros involved. And so it uses Visual Basic macros and other sorts of advanced features that are potentially can create security risks if you don't trust the person who's built them. So when you hit yes, that I want to look at the statistics, Arena opens up this file. And this file, if you've never opened it up before, it's going to not run those macros. And so if you just open this file and you don't hit this enable content, then you're going to get these stale. It's not going to actually connect to the database. It's not going to show you any data. So that's why here it says your model is c:model.p and the model run date is in 2023 in this case. If I click enable content, because I trust Rockwell Automation at this point, then it's going to start loading all of the backend that connects this XLSN file to that database. And after it loads all that up, I see very different information. So if I go to this project information sheet down here, then now I see the actual model file. It ends in .p. That's kind of like a compiled version of your DOE file. And it tells me the right model run date. And it tells me how many replications I'm running. Basically, it tells me the information that I find in that run setup. It just echoes that here. Now, it's easy to miss all of these tabs down here, these different sheets. And so if I click on them, then I can see this is my across replication summary. So remember, we ran 10 replications. And so if I look across here, like this enter the belt.q, well, if I was to go back to my Arena file, then I see that I've got down here, maybe I'll zoom in so that we can see this a little bit more. So I'm hitting Shift and then plus in order for me to zoom in on this. And if I look down through here, I've got all of these different create blocks, these different assign blocks, there's stations, and there are these processes and so on. And so some of these processes are going to have queues. And so if I were to go into the data definition here and go to queue, then I would find that there are 5 queues in this model. One of them is enter the belt.q, the other one's processing post.q, and so on. So if I go back to my, I'll get rid of this model. If I go back to my model, so I'll close this guy so I can go back to the model here. Then I see there's my processing post.q. Here is another processing post. I'm looking for the enter the belt, which I don't see right now off the top of my, very quickly. But but in each one, like if I go to processing post here, I see it does a seize delay release. The seize delay release is going to require a queue to be generated, and that's where that processing post.1 queue comes from. So those queues have statistics, and so that's what's showing up here. Is like, so what this is saying is that that at the end of every replication, we can ask how many parts reached this queue, And of all the parts that were in this queue, what was their average waiting time? Now that's for one replication. This here is the average of replication averages. So if I look across all 10 replications, each replication has an average of all the parts that were waiting in this queue. But then I average across all those replications, and then that's where I get this average of replication averages. And so I see that across all my queues, their average of replication averages. And then if I scroll over a little bit here, not only do I have an average, but I have confidence interval information. So I have half width of a 95% confidence interval. I have a standard deviation of the replication averages, which if you know the standard deviation and how many replications, you can calculate the half width. I have minimums and maximums. Again, those are mins and maxes of the averages. So across the 10 averages, what was the minimum average? And across the 10 averages, what was the maximum average? Now, if you're actually interested in the overall min and max value, then they've got those here. So this is across all of the replications. Within each replication, there's a min waiting time and a max waiting time. So then you can then take the min of the min waiting times and the max of the max waiting times, and that's what you've got here. And then average observations per replication. We'll keep in mind that in some replications you might get 160 parts, in some replications you might get 150, in some replications you might get 165, just depending on the timing of arrivals and how things push through the system before the end time. And so that's what we're seeing here. So this is the across replication summary. So not the summary for any individual replication, but the summary across replications. And we see all of that located here. Now, notice that these are the discrete time statistics. This scroll bar here leads you to a very, very, very wide sheet. So there were the discrete time statistics, and then over here, there are continuous time statistics. So the continuous time statistics here, so maybe I want to make this a little wider here, and I can make this one a little wider too, so I can see that the continuous time statistics here show me things like number waiting. Why is that a continuous time statistic? Well, at any instant of time, you can ask how many are waiting right now at this instant of time in that queue. And so you can now take the integral of that continuous function over time and divide by that time interval. And that's what gives you these time averages, these continuous time averages. So this number waiting here, this is saying in this queue, what is the average of replication averages, where that replication average is a time average for that replication. So for every replication, they take that integral underneath the number waiting function. So there's a number waiting for every single continuous time. Take the integral underneath that. And then that integral that's underneath that, you divide that by the duration, and then you end up getting an average for the replication. And this tells you the average of replication averages. And then you can get a half width. That half width is defined across your 10 averages. And so from those 10 averages, you can get a standard deviation, and from it, you can calculate a half width. And that's what that's all about. So those are our continuous time statistics. They exist for queues. They also exist for the resources themselves, like operators 1 through 4. So if you scroll down through here, you see a wide variety of continuous time statistics. Now, if I keep scrolling to the right, then I've got counter statistics. And so I don't have a lot of counters going on here, but I do have some of them. And so like under the assembly line, we've got a count of these products here. And so this is saying that there are 159 products that we saw. So this count, this is at the end of every replication, there was a value of this counter. And so across all 10 replications, there were 10 of these counts. And this is the average of those 10 counts. And if I keep scrolling to the right, then I've got additional output statistics. So these are the things that are defined as outputs per replication. And some of this was determined by when I went to those run parameters, when I went to run setup and then the run parameters, and I checked those boxes to say, I want you to keep track of these things. The choice of what it was keeping track of, the choice of what we're seeing on the sheet, in part came from what I was checking off there. And so there are certain output statistics here. So at the end of the replication, how many of this operator were seized, what was the utilization. So if you scheduled so many of these operators to work, then what was the utilization of those operators? So this is sort of a representation of how idle they were. How many parts in did we get? How many parts out did we get? And so on. I can keep scrolling to the right, and then I get frequency statistics. Now, for this particular model, we don't have any frequency statistics, but there are ways of generating frequency statistics as well. So how frequently did certain things happen? Kind of histograms that occur at the end of these replications, and they can be summarized then here. Now, that whole thing, this entire really wide spreadsheet, is the summary across the 10 replications. Now, sometimes you want to then study not just what's going on across all of those replications, but you'd like to see what happens within a replication. And that's what the rest of these sheets are for. And I can even show you that this goes even farther. So I can click on this thing over here to go through all my sheets, and I can see that after project information across replication summary, all of the rest of these sheets or these tabs down here are by replication. So they now look at what happens per replication. So I would click on discrete time by rep. Then I see that I've got this column replication, and I've got things that we've seen aggregated under the across replications tab, but now they're broken up. So if I really want to see what was the waiting time, what was the average waiting time at the end of replication 1, that's this one. What was the average waiting time at the end of replication 2? That's over here, and so on. So these 10 numbers, the average of them is what we saw on the across replication stat for this particular measure. Now, notice that it can't calculate a half width for these. Unless you run really, really long replications, then this will always be insufficient or something similar to insufficient. Basically, if you run really, 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 really long replications, Arena will try to break your replications up into batches that are uncorrelated with each other, so that one batch is so long that the information in the next batch is independent of the information in the previous batch, turning one long replication into something like several independent replications. And if it can do that, if your replication is long enough that it feels confident that one batch is independent from the previous batches, it will try to calculate a half width here. Otherwise, if your replications are relatively short, or if batching doesn't make sense for this particular statistic, then you'll get a nonsense value here or something like insufficient. Now, minimum and maximum, we can calculate those. Number of observations, calculate that. This is just for this queue across all 10 replications. Now, across the entities, you can also break those up per replication. So these are the entities here. These are particular discrete stats, discrete time stats that are they're calculated for this entity. In this case, these are cost variables. So we can say at the end of replication 1, what was the average non-value added time accumulated per entity? What was the average total time per entity? So the way you interpret this is that on average, in replication 1, there were 150 entities in replication 1. And across them, on average, they spent 19.3 minutes of total time in the system. They spent 9.6 minutes of transfer time. They spent 9.65 minutes of value added time. And that was basically most of the time they spent in there, because that's like, add those two things up and you're roughly there. They did wait in queues, but they didn't wait in queues for that long. So that's what we're seeing here. But that was only during replication 1. So now replication 2, I can look at that and I can say, well, in replication 2, then the average entity spent a little longer in the system for that replication. So it was kind of a more bad luck replication. Replication 3, then we can see that the average entity spent a little less. So that was like a good luck replication. and so on and so forth. And so we see that all of the stats are broken up by replications here, and these are the discrete time stats. This is not, I mean, it's a little wide, but all of the gray stuff here on the right here are all information that have to do with those particular stats. There's no hidden tables here on the right like there were in the across replication summary. So if you're looking for continuous time stats, you have to go to a new tab, and that's here, the continuous time stats. Same idea. I won't belabor this too much more, but like you can see, there's a replication column, and so we can see across replication 1, here are the continuous time stats for the queues, for the resources, for the entities, for more of the queues. These are the single replication averages, the single replication minimums and maximums, and so on. If I scroll down, I see another group of those, but this time it's for replication 2, another group for replication 3, and so on. And so each one of these, so if you pick any row here, if you find its match with another replication number and you assemble those 10 numbers, those averages will what were showed up on the across replications tab. You can do that also for the counters. So here are the counts of products. So you can see there's variation in the products that were counted up at the end of each one of these replications. So there's these 10 numbers, you take the average of that. That's what showed up on the across replication stats. Here are the other special output stats, again, by replication. Those get averaged up to form the output stats across replications. And again, frequency stats for this sim, we didn't use those. So this is all empty here. And so that's how we find all of that information in this Excel-based front end to the database. Remember that when this opens, the first time this opens, you're going to get that warning, and you have to enable the content in order to bypass that warning so that it will then go in and load the database information into the Excel. Otherwise, it's going to look like an empty spreadsheet. So all these tabs will be here, but as you go to them, they won't be populated. Okay, so that's Excel. Now, what if you don't have Excel installed? What if you just don't like this interface? Is there anything else you can do? Yes, there is. There's a fallback. So I'm going to close this guy. And if I go back into this folder where my DOE file was stored, so this is like your model file. This is kind of like a compiled version of that model file. And these auxiliary files are where Arena stores information after the run and so on. So it's sort of auxiliary information that helps Arena collect stats and process your sim. Everything's kind of hidden in here. If you know how to open that, you can peruse that. But there's a human readable version here in this out file. So Arena is built on an older, much older simulation language called SIMAN, and SIMAN only had a one way to kind of dump its stats out, and that's where in these text files, these out files. Now, if I right-click on this, I can say Open With and select a text editor. So I'm just going to select Notepad. If I double-click on it, because I don't have anything associated with it, Windows will ask me, what do you want to open this in? And I would just say Notepad. If you have a text editor that's your favorite, you can open it in that. You should also be able to open it in Microsoft Word. The formatting might not be as nice. So when I open it in Notepad, then I see this assembly line.out, and it basically has the same information, maybe a little less, but all of the same basic information that I saw in that Excel front end. And so right here, I've got at the top here, summary for replication 1 of 10. So this is the per replication output. So for replication 1, here are things that it collected data on. Here is the replication 1 average, the replication 1 minimum, replication 1 maximum, and so on. So here's my entity value added time, my entity's waiting time, my entity's total time. So as we saw in that previous spreadsheet, the average total time for these entities was 19.3 minutes, which matches here. So we've got all of that, and those are tally variables. So you can think of those as those either type of discrete variable. Down here, we've got these discrete change variables. You can think of these as your continuous variables. And so just for replication 1, I'm going to show you the across replication in just a second. Just for replication 1, you can find those continuous variables here. So this is the average work in progress. Work in progress is a continuous variable. because you can ask for work in progress at any instant of time. It doesn't just happen at specific events. It happens for all time, and you can average that. And again, using that integral and dividing by the duration. So we can ask for the average, we can ask for the maximum, the minimum, and so on. So we've got all of those continuous values here. We've got our counters. So at the end of replication 1, the count products counter reached 150. And then we've got those outputs. And so these are things that have been flagged as special outputs to collect. And so we've got them here at the end of replication 1. And then we end replication 1 and we do that. And then it does the exact same thing for replication 2, 3, 4, all the way down through the file, all the way up to replication 10. Then after replication 10, so you see as I'm scrolling down here, here's replication 7. I keep scrolling down. Eventually, I'm going to hit replication 9, and then replication 10 will be right after this. Replication 10. So if I scroll to the end of replication 10, then it gives me my output summary. So this is like that first, or I guess second tab in the Excel front end for the database. And this shows me the average of averages. So for the number out, so this is on average across all 10 replications. This was the average number out of the system. This is my confidence interval, or sorry, this is my confidence interval half width. This is my min. By min, it's a min of mins, and max, this is a max of maxes, and the number of replications. So I've got all of those here for my outputs. They're summarized here. So anything that was tagged as an output in one of those replications gets aggregated and then placed here. So it isn't quite as much information as you see given to you automatically in the Excel-based front end, but it's a pretty good start. And if you have all of these per replication information, you can calculate a lot of stats yourself. You just have to get this, you might have to be clever in how you open this up and do the automatic processing of these data. Now, you can add your own outputs. You can actually tell Arena to write things directly to text files or other database formats as you're running the sim. So there's a bunch of different ways you can get data out of Arena. But the quick and dirty way to just quickly get data out of Arena after you've built the model and you haven't wanted to build your own way to write out to files as it's running is to make use of these tools. This is what replaces the old Crystal Reports tool that used to be embedded within Arena. And it's probably just how they're going to move on with things moving forward. So I hope that was helpful, and it gives you a path forward with this new version of Arena. And I'll try to, in later videos, try to provide more insights into these changes that have occurred as we moved from older versions of Arena through Arena version 16.2 and forward, where 16.2 forces us to use this very new and very different interface for Arena. Thanks for your time.